Today we will discuss integration by substitution method. What is the idea of substitution? If we want to integrate a function of function, that means f of phi x into phi dash x dx. This is a very typical type of problem because we are watching the idea function of another function, that is phi x is another function, and that is function of function concept, similar to something like chain rule in derivative, not exactly. So this type of problem, how to solve? We will use substitution method. Let us see the problem. What is the problem? The problem is like this: x root over 2x square plus 3 dx. In this case, if we watch, it can't be solved algebraically because 2x square plus 3 cannot be taken square root. But we have to simplify and then integrate, but we cannot integrate because the expression in the under root cannot be simplified. So it is a function of function, 2x square plus 3 under root. So this is the phi x, that inside part. Phi x means the inside function. So we'll write I is equal to, means integral is equal to, then let t is a substituted variable, 2x square plus 3. Now we will differentiate this t to get the value of dx. How to get the value of dx? Means to find dt by dx from here. Actually, dt by dx is a differentiation. Yes, derivative of 2x square plus 3 will be 4x. Now what is happening? We want this dx value. That means we can write dt is equal to 4x dx. Actually, instead of writing this expression, we can write from here to here directly. This is called differential concept. That is, dt is the change of t, which is dt, and the 2x square plus 3 change will be 2x plus 3 derivative, that is 4x into dx. This idea can be used, but if we are not fully conversant with that idea, we can do this way. Now we will watch what is there. X dx, this x and this dx. That means x dx is present. This is x dx, but we are having 4x dx. Therefore, dt by 4 will be x dx. So what we are finding in integrating this expression, that when we will take root over 2x square plus 3 into x and then dx, then we will assume that we will substitute the variable, the portion of the function 2x square plus 3 as t, and after differentiating it we will get 4x. So dt is equal to 4x dx. Adjusting, we will get x dx. That means now we will get that x dx as dt by 4. And what about 2x square plus 3? This x dx together, these two together, we are writing dt by 4. And this expression inside is t under root. So now what is happening? In this initial stage, we cannot integrate because 2x square plus 3 can't be simplified. But now what we are finding, that dt by 4, this 4 is expression constant, we will take outside, and root t is t to the power half dt. So our task is now easy and done. What is the idea? T to the power half plus 1 by half plus 1, because this t to the power half is similar to x to the power n with respect to x, t to the power half with respect to t. So our result will be t to the power 3 by 2 by 3 by 2 plus c. So finally what we find is 1 by 6. T to the power 3 by 2 means the expression, the original expression, that was 2x square plus 3 to the power 3 by 2 plus c. 2x. Now let us take another example like this dx by cube root of ax plus b. In this case, what is happening? We are cannot directly integrate because this is actually ax plus b to the power 1/3. Ax plus b to the power 1/3. That is actually integration of a function, but the inside part. So we can start with y. We can take ax plus b as t. This is important because we are finding that ax plus b cannot be simplified. X to the power 1/3, that's x to the power n. This is not x to the power minus 1/3 or 1/3. It is actually ax plus b to the power 1/3. So let us take the inside part as t, this ax plus b. So dt by dx if I take, that will be a. dt by dx means derivative of t with respect to x, which will become a, and taking dx here. Instead of writing there, we can directly write. So if you watch this one, dx is there. So we need dx. dt by a is dx. Now we'll come back to the problem. If I come back to the problem, what we are finding that the expression is becoming I is equal to 1 by cube root of t dt by a instead of dx. Now if this 1 by a is a constant, we will take it outside, integration of t to the power minus 1/3 dt. So we are now clearly getting the expression to integrate, and the integration of this one will be 1 by a t to the power 2/3, because minus 1/3 plus 1 divided by 2/3. So plus c, final answer is 3 by 2a t to the power 3 by 2, that means 2 by 3, that means ax plus b to the power 2 by 3 plus c. So this is your answer. Instead of t, we have replaced the value. Now we can have some more type of problems. We have to simplify and solve. We cannot solve, we cannot simplify, but what we need to substitute, like dx by x log x into log of log x. It's a big question apparently. That means if you look at this question, it is x into log x into log of log x. So many log ideas are coming. What I can observe is what is the differentiation of log x? It will be actually 1 by log x into, again log x derivative is 1 by x. So let us take this portion as t. Why? Because we are having this idea that whatever is function, the derivative of that will be adjusted. That means if I take t is equal to log of log x, then what would happen? dt will be dt by dx actually. Log of log x derivative is 1 by log x. Then again log x derivative is 1 by x. And that is multiplied with dx. So what you are finding that dt is dx by x log x, which is clearly observed from here. So what you are finding in this problem is this expression is t and this expression is dt, because dx by x log x. So we replace that in the question now. That means integral part I is equal to dt by t. This part is dx by x log x is dt, and this part is taken as t. So our final answer is t to the power minus 1 integration, which is log t. So t we have assumed as x log x, log x. So we'll write the final answer as log. So this is a very important type. So this type of problems are in substitution. That means in integration, if you want to integrate, we need to simplify algebraically, and whenever we cannot simplify, we have to use the idea of substitution idea. So what is the substitution idea? Such an idea that we have to get the derivative of that portion also. Like it's a simple problem, x plus 1 square root of x square plus 2x plus 5. Here also we are finding the same problem, x square plus 2x plus 5. We cannot simplify, we will take that part as t. So when I am taking t is equal to x square plus 2x plus 5, then dt, that is a derivative dt by dx we can say, but we are writing dt to get 2x plus 2 into dx. If you watch this question, that is x plus 1 dx, taking 2 common. 2 common means dt by 2. That 2 comes from this expression, to give you x plus 1 dx. So if you go back to the problem, we are finding x plus 1 dx is dt by 2 and the denominator will be t, that is root t. So our final expression now is 1 by root t dt by 2. This dt by 2 is due to x plus 1 dx. We'll take half outside, t to the power minus half, because denominator is t to the power half. Now we will integrate half t to the power half by half plus c, that half comes from minus half plus 1. So finally answer of this question is root t, and root t is root over x square plus 2x plus 5 plus c. These two and these two cancelled. So this is the expression. Now one very special type of problem is there is a very important type, that is rationalization type. Sometimes we have to rationalize to get rid of the root from the denominator. So if we have this problem like dx by root over 2x plus 1 minus root over 2x plus 3, 2x minus 3. This problem we have one difficulty, that denominator cannot be simplified, but we have an idea that it is called rationalization. We can remove the root from the denominator. How to do that? We will multiply the denominator by the conjugate, that means the sign of the root part in between the root part will be opposite, reversed. 2x plus 3, this is minus, we will take a positive sign, 2x minus 3, multiplying this one in the numerator also. So we are multiplying an extra factor, 2x plus 3 and 2x minus 3 in the numerator and denominator. Why? Because this will give us a scope to get rid of the denominator root, because now what you are having in the denominator, it will be a square minus b square. That means 2x plus 3 plus root over 2x minus 3, and the denominator is 2x plus 3 whole square a square minus root over 2x minus 3 square, a square minus b square. So the formula is a square minus b square. That will give you the square root part is removed, and we are having 2x plus 3 under root plus root over 2x minus 3. Denominator is 2x plus 3 without root minus 2x. This sign will change, this negative sign, make it plus. So denominator becomes now 6. So now we are having the question like this: root over 2x plus 3 plus root over 2x minus 3 by 6. We can take 6 outside to get the problem as 1 by 6 root over 2x plus 3 plus root over 2x minus 3. So two parts, two integrals. Actually we are having two questions. One is root over 2x plus 3 under root, another is root over 2x minus 3 under root. We will separate in two parts. 1 by 6 integration, that is 2x plus 3 to the power half dx, and then 1 by 6 again, because this 1 by 6 should be both the integral part. We are separating 2x minus 3 to the power half. So we can take assumption that substitution. If I take the first substitution, let t is equal to 2x plus 3, then we are observing that dt will be 2 dx. But we are not having any 2 dx, we will write dt by 2 is equal to dx. Similarly, if I substitute the second part by p, it will be 2x minus 3 and dp is equal to 2 dx, dp by dx is equal to 2, because we are differentiating p. dp by dx is 2, so 2 will be here, therefore dp by 2 is equal to dx. So we are having two integral, two different substitutions, and we will put there. That means our problem will be 1 by 6 t to the power half dt by 2 plus 1 by 6 p to the power half dp by 2. So ultimately 1 by 12 p to the power half integration dt plus 1 by 12 p to the power half dp. In both the cases we will apply x to the power n rule, and when we will apply x to the power n rule, our result will be 1 by 12 there, t to the power 3 by 2 by 3 by 2 plus 1 by 12 p to the power 3 by 2 by 3 by 2 plus c for both the integration constant. So we are getting now the answer as 1 by 18 in both cases. Common, we can take t to the power 3 by 2. T to the power 3 by 2 is 2x plus 3 to the power 3 by 2. Again 1 by 18, 2x minus 3 to the power 3 by 2 plus c. So this is the expression. Now we can take one last problem in which, for today's discussion, that in all these cases we are having one advantage, that dx and dt are adjusted. I am taking one example, one last example where we will be having some problem, and the problem is like this one. If I have a question like this, it's a special problem, because if I have a question like this, x plus 1 by 2x plus 3, then we have a simple problem that 2x plus 3 we cannot simplify because it is in the denominator. We cannot divide directly. Yes, sometimes we can apply. So let us take t is equal to 2x plus 3. This type. T is equal to 2x plus 3. So we have to differentiate dt by dx. What we have done, that is dt by dx is 2. Therefore dt will be 2 dx. That means dt by 2 will be dx. Now what is happening in numerator? We are getting an extra x, this x. So that x is the problem. How to get rid of that x? Look at this expression. T is equal to 2x plus 3. So what we can think, that this x can be simplified. This x. 2x will be t minus 3. Taking 3 this side. That means x will be t minus 3 by 2. So go back to the problem. Now go back to the problem. We are going back to the problem by writing t minus 3 by 2 plus 1, that is x plus 1 in the integration portion, divided by t, we have assumed it by t, and dt by 2, that is the dx portion. This is the integral. This is x plus 1, this is total part is t, and this part. This is a very typical type of problem. Now we will simplify t minus 3 plus 2 by 2, and this t will remain in the denominator, because this is t by 1 actually. So this is t by 1, so we can write 1 by t, and that dt by 2 is there. So what is happening? We are getting 2 2s are 4 outside, that is 1 by 4. And then the numerator, t minus 1 by t. This t is there. This t is there means this t is this t. So now we will simplify further. That is 1 by 4 t by t dt. This is first part, minus 1 by 4 1 by t dt. So our finally problem is becoming 1 by 4 1 dt minus 1 by 4 t to the power minus 1 dt. So this is 1 by 4 t minus 1 by 4 log t. We know that t is t, 2x plus 3, putting there 1 by 4 2x plus 3 minus 1 by 4 log 2x plus 3. We can do this problem in a different manner, in a shorter manner. But what I have tried to discuss is the general idea of substitution. This should not be the final answer, because if you open this, we will find one important thing to notice. 2x by 4 plus 3 by 4 minus 1 by 4 log 2x plus 3. We can simplify one thing. This 3 by 4 has no x and this c has no x. So we can club these two together. This is x by 2 minus 1 by 4 log 2x plus 3. Then this 2 together becomes a constant as c dash. It's a new constant which comes from 3 by 4 plus c as a new constant. So this is our final answer. That is this concept of substitution in algebra. We have to substitute such a way that finally we can solve the problem and then integrate to the result using dt what we have substituted. This is all about substitution method of algebraic type. That's all for today.